Okay, YouTubers, this is Jared talking to you from the Armory, and the precarious perch that this cell phone is on is hilarious. I'm using some screwdrivers against the wall to hold the phone. It's pretty funny. Anyway, I wanted to do a little bit of a video just to show you how I test the hardness on these tomahawks and such after they're heat treated. So this is a calibrated set of files, and they range from the hardness of the file from 40 up to 65 by 5 Rockwell points on the Rockwell scale. So what I do is I start with the hardest one, which is a 65, and the thing about 1095 is that it's sort of a differential hardness type of process. You can see hopefully in this picture the little rainbow colored concentric arcs on the underhook edge, and that signifies the different rate at which the steel cools off when it's being quenched. That feels very hard. And then if I was to cut a little bit on the surface here, I'm gripping that no problem. So now it's going to move down to the Rockwell 60 and check the edge. So that is cutting just a little bit, and it's, see if I'm cutting here. Yeah, it's still cutting that too. I'm not expecting to get 60. I'm expecting to get somewhere between 52 and 50, and that is skating along nicely. That is not cutting at all, but I'm still cutting on the surface, and that's what we're supposed to happen. Anywhere where the thickness is, you can hear the difference there. It's like a skating action and then cutting action. See, it doesn't ring as much. So this is 55. This is over Rockwell 55 on this part of the edge, or real close to it. So that's how I test the hardness on the 1095 or any kind of os-tempered blade, because the end quench hardenability of 1095 makes it so that it's a differential hardness depending on the thickness of the cross section. So that's why everything gets ground prior to heat treat. That way I get a nice hard edge and then a softer body, which makes it shock resistant. And also, if you do break the thing, it's going to yield, or if you abuse the thing, it's going to yield and bend before it breaks. So that way you never have a perfect elastic movement of the steel. You have a plastic deformation, which means if you bend the thing, you're going to feel it move before you break it and fall off a cliff, like if you're prying something. Everybody's pried something and then had the thing snap in their hand, and then they break a knuckle or do something else that hurts. So that's a hardness check, and you can see where it was done at the heat treater, where they scraped that right there and down there to do the checking before I got my hands on it. All right, there you have it.